Hello everyone, good afternoon. Welcome to Prep Station. This is chemistry. I want to take you on organic chemistry precisely to show you how questions are being set and how to answer some questions on organic chemistry. Hydrocarbons. So on this course, we're going to look at definition, the classes of hydrocarbons, tests for unsaturation, the sources of hydrocarbon, the homologous series, functional group, alkyl group, characteristics of homologous series, then different formulas in organic compound, then the IUPAC nomenclature of organic compounds. Then we take some activities, we proceed to isomerism. Okay, definition, hydrocarbon. Hydrocarbons are organic compounds that compose of only carbon and hydrogen in their chain. Are organic compounds containing only carbon and hydrogen in their straight chains. They have general formula of CXHY, where X and Y are positive whole numbers. It can be 1, it can be 2, it can be 3, they must be whole numbers. Examples are the methane CH4, ethane C2H4, propane C3H8, and so on. Okay, the classes of hydrocarbons. Hydrocarbons are divided into two major classes, which are the aliphatic hydrocarbons and aromatic hydrocarbons. Now, what are aliphatic? Aliphatic hydrocarbons are those carbons that are straight, that have straight chains or branch chain. They have straight chain structures having what? No rings in them. They're always straight or what? Or branch. Then the second one there is aromatic hydrocarbons, which are also called what? The arrays, meaning they are compounds which consist of at least one aromatic what? Ring. At least one aromatic what? Ring. Okay. Then under aliphatic hydrocarbon, we call the acyclic hydrocarbons. Now these are straight or branch chain aliphatic compounds. Example, the alkane, and what? And the alkyne. So all these alkynes are either straight chain or branched chain. We also have cyclic. Cyclic hydrocarbons, example is a cycloalkanes. Precisely cyclobutane. These hydrocarbons possess one or multiple carbon rings. The hydrogen atom is attached to what? To the carbon what? Ring. Okay, we also have what we call the saturated hydrocarbons. These are compounds who contains only single bond between their carbon chains. In this compound, carbon atoms and carbon atoms are held together by single bonds. These single bonded compounds are the simplest hydrocarbons. This type of hydrocarbons don't have double or triple bonds. So they are mainly composed of single carbon-carbon bond or single carbon-hydrogen bond within their molecule. We also have the unsaturated what? Hydrocarbons. These are hydrocarbons which contain either a double bond or a triple bond in between their straight chain. For example, we have the alkenes and the alkynes. The alkenes and alkynes are the major examples of what's unsaturated, meaning that alkene contains double bond prepared by CnH2, and this is a general formula for what? For preparing what? Alkene. While the alkynes contains what? Triple bonds, and general formula is what? CnH2n minus what? 2. All right. Now let's take a brief description to further get the topic right. We have hydrocarbon, which is classified into what? Into aliphatic, then aromatic. So these are the major class of what? Hydrocarbon. Then aliphatic is further classified into what? Into acyclic and also what? Cyclic. Now under acyclic hydrocarbon, we have what we call the straight or the branch chain hydrocarbons, which comprises the alkane. We also have the alkene Then lastly, we have what? The alkyne. Now, the members of the alkane can be prepared by using CnH2n plus 2. This is general formula for what? Preparing all the members of what? Of the alkane family. Whereas members of the alkene can be obtained by general formula of CnH2n minus what? 2. Now, these n's are what? Are whole numbers, depending on what? Depending on the type of homologue present. Then the alkynes can be prepared using CnH2n minus, H2n minus 2. This is for alkyne, this is for what? Alkyne. Then example of cyclic. Cyclic means cyclic hydrocarbons are derived from where? From the alkane. Meaning that, okay, let me give you one example of the alkane. If I'm using butane, butane is prepared by is C4H2n times 4 plus what? 2, which gives us what? C4H, 2 times 4 is 8 plus 2 is what? Is 10. For example, this is butane from where? From alkane homologous series. Now, to get a cyclic hydrocarbon from where? From the alkane, you convert this guy, this butane to what? Into a ring. By what? Shorting 2 hydrogen atoms. So if you convert this guy, you give us what? You give us something as C4 what? H8. Now let's take a diagram to see how it goes. So this is a normal stress chain hydrocarbon with C, 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 C. All others are what? Are hydrogen atom attached to each of the carbon atom. Hydrogen atom, hydrogen atom, hydrogen atom, T. So if you convert this guy to cyclic, you're going to form a ring out of what? Out of the butane. So that will give us what? C, 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 with all single bonded carbon atom. So don't forget that carbon is a tetravalent element. So any bond that surrounds carbon must be tetravalent in nature. 1, 2, 3, 4. So if you have something like this, it is wrong. So every bond surrounding carbon atom must be what? 4. To what? To align with the tetravalency nature of what? Carbon atom. So with this to give us what? 1 hydrogen, 1 hydrogen. So this is 1, 2, 3, 4 bonded to what? 1 carbon atom. We have 1 hydrogen, 1 hydrogen, having 1, 2, 3, 4 to 1 carbon atom. We also have the same thing here, hydrogen atom, hydrogen atom. So if you count, instead of having C10, C4H10 with regards to normal butane, here you have what? C4. Let's count hydrogen atom. 1, 2, 3, 4, 5, 6, 7, 8. So you now have C4H what? 8 as cyclo what? Hydrocarbon. So all cyclo compounds are gotten from where? From the acyclic, either alkane, alkanes, or what? Or the alkyne. Okay. Now, a typical example of the aromatic hydrocarbon is the benzene ring. Benzene. You know that benzene is C6 what? C6H6. So that will give us what? 1, 2. All this contains what? Carbon atom. Carbon atom. So this is 1, 2, 3, 4, 5, 6. Now don't forget that it is a member of alkene. So that means that there is a double bond in between what? Some of the carbon atom for the benzene. So this is carbon with double bond, double bond, double bond. So this is 1, 2, 3, 4, 5, 6. So how many hydrogen atoms do we need? Because of the tetravalency nature of carbon atom, we need just 1. This other bond contains what? Hydrogen. This contains what? Hydrogen. This contains what? Hydrogen. Till you get what? Your benzene what? Ring. So if you check, this is what? C6H6. 1, 2, 3, 4, 5, 6 carbon atom. Then 1, 2, 3, 4, 5, 6 hydrogen what? Atom. So this is general overview of a classification of hydrocarbon. Aliphatic, aromatic. Under aliphatic, we have acyclic and cyclic. Under acyclic, we have the alkane, the alkenes, and the alkyne. Then under cyclic, we have, for example, cyclo, alkane. Is that precisely we have cyclobutane. This is cyclobutane. 1, 2, 3, 4 with 4 carbon atoms. Then under aromatic, we have a benzene what ring, and other compound that forms ring like benzene. So that is how to classify what hydrocarbon. As I said earlier on, alkane are saturated because of what? They all contain single bond between their what? Their straight chain. And also, alkene contains what? Double bond. While the alkyne contains how many? Triple bond between their carbon chain. That is why we classify them under unsaturated hydrocarbon. Alkene, alkyne, unsaturated. Alkane, saturated. Okay, let's move on. Let's see how we can test for unsaturation in hydrocarbon compound. Now, the first point is to recognize them by their addition reaction. All the unsaturated compounds undergo what we call addition reaction. That is the alkene and the alkyne. Secondly, if you subject a compound containing unsaturated hydrocarbon into a bromine water or a reddish brown bromine, it will change this compound to what? To colorless. Meaning that that compound contains what? Unsaturated what? Hydrocarbon. Thirdly, if you have a purple color of, this compound is called potassium heptaoxodichromate. Potassium tetraoxomanganate 7. So if you subject a compound containing unsaturated hydrocarbon into this compound, it will convert the color from purple to what? To colorless. Meaning that compound will what? Contain unsaturated what? Hydrocarbon. Okay, let's move on. Then, what are the sources of hydrocarbon? Natural sources, we have coal. You can obtain hydrocarbon from the coal. You get it from natural gas, then the petroleum, and the natural sources of what? That is it. Coal, natural gas, petroleum are what? Are natural sources of hydrocarbons. Now, what are coal? Coal is a solid fuel. Petroleum is also what? A dark viscous what? Liquid fuel, while natural gas is a gaseous what? Fuel. Homologous series. Now, homologous series is a structural pattern in which every organic compound follows that help us to classify them in their respective what? Homologues. Every organic compound has where they belong, just like everybody have their own special family. Okay, so, yes, homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differs in its molecular formula by -CH2. Now, every member of each homologue differ from each other by having what? CH2. For example, I will give you an example later. Now, each individual member is referred to as homologue. For example, I talk of the alkane initially, that the alkane can be formed using CnH2n plus 2. So this is a formula, this is an homologous series called alkane. And every member of this homologous series are called homologue. For example, the first member of the alkane is what we known as the methane. Methane. So, if you substitute the value of n with 1, you'll have C1 H2 times 1 plus 2. That will give us what? CH what? 2 times 1 is 1, then 2 plus 2 is what? Is 4. So this is the first member of what? Of the alkane family, gotten from what? General formula with a single bond. Don't forget, all this alkane family contains what? Single bond. Then the second member is what we call the ethane. Do the same thing, you will notice that you will have C2H times 2 plus 2. So that will give us what? C2, 2 times 2 is 4. Then 4 plus 2 is what? Is 6. You have C2 what? S6. Now instead to have, instead to waste your time to be calculating this from a formula, simply do what? Go to the definition of what? Homologous series and add CH2 to it. So if we do that, the next one, before we go for a break, will be what? Propane. So add CH2 to C2H6. You will have what? C3H what? 8. And so forth. Okay. We shall come back for the second segment of this program. Stay tuned.